Now, having understood that, it is time for making some more solids. Let's take a square. If I extend it by the same distance as its side length, I get something which is known as a cube. If I start with a rectangle on the other hand and extend by some distance, I get a cuboid. The difference between a cube and a cuboid is that all the sides in a cube are equal, but in a cuboid, they are not. See, it is so easy to create 3D objects. Want to try one more? Extend a circle by some distance. What you get is called a cylinder. Now, let's move on and calculate the volume of all of these objects. We calculate the volume in two steps. In step 1, we find the area of the 2D figure, and in step 2, we multiply the area obtained in step 1 to the height to which it was extended. The value that you will get after step 2 is nothing but the volume of the solid that you wanted to calculate. Now, let us try and implement these steps. Let us find the volume of this cube, which has got a side length of 1 centimeter. In step 1, we have to calculate the area of the 2D figure that formed this cube. So, the 2D figure that forms a cube is a square, right? The area of this square is going to be 1 centimeter squared. Now, according to step 2, we have to multiply the answer obtained in step 1 to the distance by which the figure has to be extended. That will give us 1 centimeter squared times 1 centimeter. Now, what will be the answer? Yes, you guessed it right. It will be equal to 1 times 1, which is going to be 1, and centimeter squared times centimeter, which is going to be centimeter cube. So, the volume of the cube with side 1 centimeter is equal to 1 centimeter cube or 1 cubic centimeter. This means that if you have a solid cube with side 1 centimeter, it would occupy 1 cubic centimeter of space. If you club both the steps for the cube, you can see that the volume is equivalent to 1 centimeter times 1 centimeter times 1 centimeter. So, for any cube, you can use the same logic. That is, volume of the cube is going to be equivalent to side times side times side, or S times S times S. Now remember that any 2D figure had areas in terms of square units. That was just not for squares, right? Any 2D figure. Similarly, all 3D objects will have volume in terms of cubic units. It is just not restricted to cubes. It could be any 3D object. Having said that, let us move on to a cuboid now. So, a cuboid is formed by extending a rectangle, right? Let us say we have a rectangle with length and breadth as 2 centimeters and 3 centimeters. So, what will be the area of this rectangle? It is going to be length times breadth, which is going to be equivalent to 6 centimeters square. Now, let's give this rectangle a height of 4 centimeters. To find the volume, what will I have to do? I have to multiply the area with the height, which will result in 6 centimeters squared times 4 centimeters, which is going to be equivalent to 24 centimeter cube. So, the volume of this cuboid is going to be 24 centimeter cube. Why am I calling it a volume of 24 centimeter cube? Because if I take a cube of volume 1 centimeter cube, then exactly 24 of them would fit inside this cuboid. That was easy, right? There are a lot of other shapes which you can actually calculate volumes of. But for now, just stick with cubes and cuboids. Now that you've learned how to calculate the volumes of cubes and cuboids, I have a very interesting question for you guys. We got 2D from extending 1D, 3D objects by extending 2D figures. What if we extend a 3D object, like say a cube? What will happen? Think about it.